Okay, in this lesson, we're going to talk about Newton's third law. So let's dive into this lesson now. So first of all, let's define Newton's third law. Newton's third law states that for every action, there's an equal and opposite reaction, and the action-reaction pairs acts on separate bodies. So what are the key characteristics of the action-reaction pairs? So the first characteristic is that they are equal in magnitude. The second characteristic is that they are opposite in direction. The third characteristic is that they act on separate bodies. And lastly, they are the same type of forces. The fourth characteristic is something that is seldom taught in textbook, but you need to know that, for example, if one of the force is a contact force, alright, the other force must also be a contact force. Similarly, if one of the force is a tension, the other force has to be a tension. If one of the force is a gravitational force, the other one has to be the same as well. So let's look at some examples of Newton's third law. Now, for example, if a rocket is traveling to the right, so there's actually two forces that's acting on the rocket. The first force is the force that the gas is pushing against the rocket to cause it to move forward. The opposite force, or the reaction force, is actually the rocket pushing against the gas, which is actually throwing the gas out of the rocket so that the rocket can move forward. Okay. Next, a car that is traveling on the road. The reason why a car can travel on the road is because of friction. Okay, the friction between the road and the tire. So how exactly friction works in this case? So what happens is that the road using friction pushes against the tire as an action. The reaction will be the tire using friction pushing against the road. Now let's look at the last case. The last case probably is something that you are very familiar with. Whenever you see a video, or you have actually experienced yourself, whenever you try to fire a shot from a rifle, there is always what we call recoil. Okay, so what exactly are these forces and why there's a recoil? It's because of Newton's third law. So what happens is that whenever a bullet is being pushed out through the rifle barrel, okay, there will always be a reaction on the soldier, which is actually the recoil. Okay, so these are also action-reaction pairs. So let us use the four characteristics as criteria to check whether the three examples that I shared just now are action-reaction pairs. So first of all, the rocket. So they are equal in magnitude because the gas is pushing against the rocket and the rocket is pushing against the gas. They are obviously opposite in direction because both forces are pointing in the opposite direction. Now, third is most important. They act on separate body because one of the force is acting on the rocket, the other force is acting on the gas, but they don't act on each other. They don't act in the same body. Alright. And lastly, they are the same type of forces. Yes, because they are both contact forces. Contact forces means forces that arises because of pushing between two objects that touches each other. Alright. So let's look at the third example, soldier firing a shot. So again, they are the equal in magnitude because the force that the bullet experiences is equal to the force that the person experiences as recoil. They are opposite in direction, yes, obviously, because one is going forward, the other one is backward. They act on separate bodies, yes, one on the bullet, the other one is on the soldier. And obviously they are the same type of forces again as contact forces. So they fulfill all the criteria and definitely are action-reaction pairs. Now, since we have already seen some examples of action-reaction pair, then what are exactly not action-reaction pairs? Okay, one classical example is a book resting on a floor. Okay, and another classical example is a block being pulled with a string with a tension T and a frictional force F acts against the motion. Okay, so these are two classical examples. The first example is the most commonly misunderstood example, because even some textbooks use this as an action-reaction pair when it is not supposed to be. Alright, so let me just explain why this is not an action-reaction pair. Now, of course, they are equal in magnitude because these two forces has to be equal in order to balance each other out, and there is no resultant force. Alright, that's why the book is at rest. They are obviously opposite in direction because one is pointing up, the other one is pointing down. Unfortunately, they do not act on separate bodies. Okay, this is actually the easiest criteria to judge whether the forces are action-reaction pairs, because in this case, the R, which is the reaction force, is acting on the book. In the same way, the weight is also acting on the book. So both forces are acting on the book, so they cannot be action-reaction pairs because they are not acting on separate bodies. And lastly, they are the different type of forces. Okay, R, which is the reaction force, is a contact force, while W is a gravitational force. So they cannot be action-reaction pairs. Alright, so criteria 3 and 4 are not fulfilled. Now, how about this one? Okay, similarly, for the first two cases, they are fulfilled. Okay, they have the same magnitude but in opposite direction. However, again, they do not act on the separate bodies. They act on the same object, which is the block. And also, there are different forces. One is a tension, the other one is a friction. So they are definitely not examples of action-reaction pairs. So with this understanding, could you try to do these three questions, find out which one is which of these examples are action-reaction pairs and which are not. Okay, you can pause the video at this point in time and try to do it now. Okay, please pause it now. Okay, so I expect that you have already paused and done the questions. So let's go through the answers. The first case is yes, they are action-reaction pair. Okay, they all act on they have equal and opposite reaction. They act on separate bodies, and they are both contact forces. Okay. Second case is also yes, they are action-reaction pair. The tension, the two forces are equal and opposite, and the tension on B acts on B. The tension on A acts on A, and both are tension, so they are action-reaction pair. And lastly, the third one is no, they are not action-reaction pair because both forces act on the same body, and at the same time both are different types of forces. One is a tension, the other one is a weight. So with this understanding, we come to the last slide of this video. We commonly understand contact forces. The reaction pair is another contact force. But how about the weight? How do you find the reaction pair to the weight of a book? Okay, as we learned in the four characteristics of Newton's third law, the reaction pair has to be the same type of forces, and it has to act on separate bodies. So definitely it cannot act on the book. So where does it act? And definitely it has to be gravitational force because it has to be the same type of forces. So the answer is actually the force that the book acts on the earth. Okay, believe it or not, whether how small or how big an object is, so long as they have mass, okay, the pull of gravity on the object is equal to the object will also exert the same pull on the earth. But the reason why the earth doesn't feel the pull is because we are too small and too light to have a very significant effect on the earth. Okay, but this is the truth. The reaction pair to the weight on the book is actually a same equal and opposite force, alright, acting on the earth towards the book. That's the reaction pair for the weight. Okay, so this is the last slide. I hope that you are able to understand Newton's third law better and able to apply to questions in your examination and in your worksheets. Thank you and have a nice day.